Welcome to Blacksburg, home of the Virginia Tech Hokies and some of Virginia's favorite restaurants and bars. Our ergonomics team, consisting of Caroline Bonis, Minh Pham, Olivia Reed, Yasmine Sikder, and Caroline Verrecchia, decided to head to one of our favorite Blacksburg mainstays to observe and evaluate the potential ergonomics risks that exist there. For those of you who aren't familiar, Sharky's is a popular bar and restaurant located in the heart of downtown Blacksburg. Sharky's has unbeatable happy hour prices and a fun, laid-back environment, and is the first to fill up on most evenings and game day weekends. To keep customers happy and tables cleared, Sharky's employees perform tasks that may be associated with increased ergonomics risks. Our project will further dive into the risks associated with clearing tables at Sharky's.
To characterize the existing or potential ergonomics problems a Sharky's employee might have, we researched risk factors that were common to bar and restaurant environments. The three most prevalent risk factors are awkward postures, forceful exertions, and a lack of proper training. This is John. After observing a typical shift of his, we found that the servers will frequently perform one-handed lifts to clear tables, a repetitive task involving awkward postures. The specific task we will focus on is the collection of empty cups around the restaurant. When empty cups accumulate around the bar, servers collect them, holding up to 30 glasses at a time. In analyzing this task, we conducted a biomechanical analysis of John if he were to carry a stack of 15 cups and a stack of 30 cups. We also took a look at the energy expenditure and conducted a rapid upper limb assessment.
Here, John is carrying 15 cups. The stack rests on John's shoulder, but as you can see from the free body diagram we cut at the shoulder to analyze its net muscle moment. The four forces evaluated are all in the FY direction: the weight of the upper arm, the weight of the forearm, the weight of the hand, and the weight of the 15 cups. The cups weigh 13.78 pounds, and the cup stack is 28.7 inches in length. It is assumed that the cups are resting at the end of the hand. The upper arm is held at 0 degrees, and the forearm and hand are held at a 45-degree angle. The net muscle moment at the shoulder M was calculated to be 108.59 pound-inches. Because the shoulder strength of a 50th percentile 180-pound male is 806 pound-inches, the task demands are well within his strength capacity. That being said, the task could still present risks as it's repetitive in nature and uses an awkward posture. Next, we took a look at the second condition, carrying 30 cups. As you can see, all the details of this condition are identical to the first, except for the larger, heavier load, which is now 27.56 pounds. John carries the 30 cups in two adjacent stacks, which does not change the vertical height or center of mass of the cups. We calculated the net muscle moment at the shoulder to be 196.49 pound-inches. Again, the task is well within the capacity of a 50th percentile male, but our concerns about the repetitiveness and posture remain.
Then we analyzed energy expenditure based on the specifications of a 50th percentile man. This analysis is typically used by ergonomists to assess the metabolic demand of workers. We wanted to calculate the total expenditure because the general rule of thumb is if the EE is less than 33% of their aerobic capacity, the workers shouldn't be physiologically stressed. Digestive metabolism is 10% of the caloric intake, which we assume to be 2,500 calories, which is average for a male. In general, the worker will expend 1,398 calories in one day. At work, an employee will expend 2,583 calories from walking for 6 hours, carrying glassware for 3 hours, and standing for an additional 3 hours, for a total workday of 12 hours. This brings us to a total energy expenditure of 3,981 calories. We calculated the aerobic capacity to be 16.7 kilocalories per minute, based off of John being a 26-year-old male, 48 kilograms, and being 57 inches tall. The recommended work rate is 4.4, and the calculated work rate is 3.6. Since the actual work rate is less than the recommended work rate, the work rate is not deemed excessive. Also, based off of the general rule of thumb that we mentioned earlier, the work rate is also less than 1/3 of the aerobic capacity.
To evaluate the way servers carry cup stacks, we used a rapid upper limb assessment. A Rula check sheet fits the task well because it is focused on the upper body, considers the force of the cups, and requires no equipment. The upper body focus was vital in the analysis of a person carrying cups because they are carried completely by their arms. Additionally, the force of the cups must be considered because of the excessive weight. And finally, we did not want to intrude on the worker's environment with measuring equipment. The first step of the Rula check sheet is to locate the upper arm position. We evaluated the upper arm angle to be 0 degrees with no adjustments. leaving a score of +1. Next, we found the lower arm position. We evaluated this angle to be 45 degrees, giving a score of +2 with no adjustments. For the wrist position, we evaluated a score of +2 because it was not extreme nor midline, so we went with the medium choice. For the wrist twist score, we evaluated it to be +1 because it is near mid-range. Using Table A, we found the posture score, compiling the scores from the upper arm, lower arm, wrist score, and wrist twist score. We found this to be 2. The task is not held for extended periods or repeated several times in a minute, resulting in a muscle use score of 0. The force/load score is 3 because the load is roughly 27 pounds. The wrist and arm score is the sum of steps 5 through 7 and is equal to 5. This value will be used later to find the row in Table C. The neck position is neutral because he is standing normally, which results in a score of 1. The trunk score is 1 because the worker is standing tall with no angle forward. Next, the leg score is evaluated to be 1 because both feet are on the ground. Using the neck posture, trunk posture, and leg scores, we found the overall posture score to be 1 in Table B. The muscle use score is 0 because the task is not static or repeated several times in a minute. The force load is 3 because the cups weigh about 27 pounds. Summing the neck, trunk, and leg scores, we get a total score of 4. This value will help us find the column in Table C. The overall RULA score is 4 based on Table C. This means that further change may be needed and justifies our investigation in the process. The highest scores are for the force load scores, meaning the load could be too heavy for the worker.
The condition of carrying a tall stack of cups repetitively leads to awkward postures, which would potentially result in long-lasting and damaging effects on his shoulder, back, or wrist. Our proposed engineering control would use a bus tub, a bin that can carry up to 20 cups, and will reduce John's exposure to frequent one-handed lifts. The bus tubs redistribute the load of the glassware and allow servers to use a comfortable grip and 2 hands instead of 1. It will also reduce the server's exposure to awkward postures and possible tendon disorders. The handles reinforce gripping and contact, which makes lifting easier and safer. That being said, bus tubs also limit the number of glasses to 20, and the tub itself might be cumbersome to carry in a crowded bar during happy hour.
Like we mentioned earlier, this task is highly repetitive and is conducted over a long period of time. To reduce risks through administrative controls, we propose to reduce shift length from 12 to 6 hours per shift, as well as increase job variance. This way, servers can routinely switch from waiting tables, bussing tables, hosting, and any of their other tasks, rather than randomly going from job to job as it is needed. We hope that this control will holistically decrease the frequency with which servers will have to carry large amounts of cups and hopefully reduce the risk of injury. With this administrative control in place, it would prevent overuse of the shoulder muscles as well as any other muscles associated with carrying large amounts of cups, thus reducing the risk of injury. Also, it would allow servers to have more flexible shift schedules, now that they no longer have to serve 12 hours in one go and can instead do 6-hour shifts as needed. On the other hand, it might backfire, as it would reduce the flexibility that workers have within a shift. If workers were to routinely switch between tasks, they would no longer have the ability to meet a need as it arises. So if there was a table full of cups and a server was currently hosting, they wouldn't be able to address this problem right away as they normally do.
To evaluate the effectiveness of our control, we repeated the biomechanical analysis with the bus tub. Here, John carries 20 cups in a bin rather than in a stack. The weight of the bin and cups is 9.48 pounds, and the calculated net muscle moment at the shoulder is 106.6 pound-inches. The net muscle moment remains lower than the shoulder strength of a 50th percentile 180-pound man, which is 806 pound-inches, and is the lowest value calculated in our analysis. Using the bin, servers can carry more cups with less strength demands than when carrying stacks of 15 to 30 cups. While this control improves the tasks, there are also limitations. At times, it may be necessary to carry more than 20 cups, all bins might be in use, or it can become difficult to move through crowds. The cost to implement this control is $9.44, which is relatively inexpensive.
In summary, servers face a risk for workplace musculoskeletal disorders not because their work is particularly taxing in any strength capacity, but because they must execute highly repetitive tasks over long shifts that feature awkward postures. Before our controls, John would carry a stack of 15 cups, which would require a 109 pound-inch net muscle moment at the shoulder, or 2 stacks containing 30 cups total, which required a 196 pound-inch net muscle moment at the shoulder. After implementing our proposed engineering control of a bus tub, servers would only be required to use a 106 pound-inch net muscle moment at the shoulder. After evaluating the effects of our engineering control, its benefits were clear. That being said, the use of bus tubs in the restaurant industry is very common, and it begged the question, why weren't they being used before? To corroborate our research, we went back to Sharky's to learn more.
Yeah, that makes sense. Do you think there's like a better way to do this? Clearly you guys have been doing it for a while, but do you think there would be a better way if you could change it?
I can't think of what.
No?
Yeah.
Okay.
Like, some people like to try to use bus tubs, but I feel like that's just, you can't carry as much, and it's harder once you get to the back to get it all organized back out.
Okay.
Have the bus tub, then when you just set down the glasses and put them in the cleaning racks.
As it turns out, using a bus tub or handheld container to move glasses is something that Sharky's has considered before. However, servers elect not to use them. Not only do the bins limit workers' productivity in clearing cups, but the shoulder relief that they provide is also not demanded. While the strength demands placed on the shoulder by holding stacks of 15 to 30 cups could be reduced, it is still well within the strength capacity of 50th percentile male workers. While the carrying position could be made more comfortable, servers do not experience issue with the current method and seem to think, why fix what isn't broken? That being said, we still believe that the working experience for servers at a place like Sharky's can still be improved by decreasing task frequency through administrative controls, like the ones that we suggested.
Ergonomics on 3, 1, 2, 3, ergonomics.